Hello everyone, in this video we will be learning about curl and divergence of a vector. कर्ल एंड डाइवर्जेंस दोनों भी वेक्टर ऑपरेटर है जो वेक्टर फील्ड के लिए यूज़ किए जाते हैं. फर्स्ट ऑफ ऑल वी विल अंडरस्टैंड व्हाट इज़ divergence, what is divergence and what is, then we will look for the what is curl of the vector field. So let's imagine I will just draw a simple diagram, like let's say this is the one vector field and I am showing like this is the vector field. So if you see this, let's say this is representing some fluid and it has some velocity is there which is representing like f vector, we will say that. So if you see this fluid is exploding, basically outward direction it is exploding. So if you want to find the behavior or the explosion of the fluid, then we use the divergence. Basically what does it tell? When it is outwards, then we can say that it's a positive. So basically it tells how the fluid is whether it is diverging or it's collecting at particular point in the vector field. So that's how it is useful, but it doesn't tell about any direction as such, like so basically this is the scalar quantity, if you understand, because it is telling whether the vector field or it is like towards it is whether it is diverging or we can say that it's like a dispersing or it is getting collected at particular point. So that's what it is useful. So it is a scalar quantity. Now how we find the divergence is it gets, first of all it gets represented by, either we can represent like a divf like a divergence of a given vector which is f vector, or we can represent with the del operator and dot product with the given vector which is f vector here. So basically you have to find the dot product over like with the del operator. Del operator हमें पता है कि इसकी how we represent it. So I del by del x of I cap plus del by y of j cap plus del by del z k cap. So this is how, and we are going to take a dot product with the given f vector. तो यहाँ पे f vector को हमने represent किया है in all three directions, like x, y and z direction के साथ हमने इसको रिप्रेजेंट किया है. सो दैट्स वाई वी हैव टेकन इट एज f1 i कैप प्लस f2 j कैप प्लस f3 k कैप, क्योंकि हमें वो तीनों डायरेक्शन में x y z it will be there, so the vector field. So that's why we have taken it. Now we will be finding its divergence. So basically we will be taking dot product. So simply what we will be doing it's I का del by del x of f1, because I के साथ if you see here जो भी आ रहा है we will be taking like a differentiating. Then this is coming with j cap along y axis, so that we have taken like इसका partial differentiation with respect to y, and इसका del by del z जो कि हमें k cap के साथ आ रहा है उसका with respect to z we will be taking partial differentiation. As I said earlier, this will be the scalar quantity. So here if you see this, whatever after finding dot product or divergence, whatever quantity we are getting, it doesn't have any I cap, j cap or k cap. That's the reason we can say that this is quantity which we are getting it, divergence of f, that is nothing but the scalar quantity or scalar function. Now physically here definition I have put it here. It gives the rate of fluid originating per unit volume at a point in vector field. I think here also in the this small, just to make you understand, I draw the diagram. That is what it was telling, how the fluid is flowing. So, the same thing here, it is put it in the definition. It gives the rate of fluid originating per unit volume at a given point in a vector field. So, this is definition. Now, here one more term is there, solenoidal and incompressible or the divergence free. It is one and the same thing. All three different words or the terms are getting used, but meaning is same. Like whenever we find a divergence of any vector, and if you see that it is 0, that time we say that it is incompressible, means the value, when even we are changing, that fluid is changing from one point to other point, still it is not making any change in its volume. That is when we say that volume is remaining constant, or the volume of that or the vector field is remaining constant basically. So, that is why the divergence is giving as a 0. So, that is when we say that it is a divergence free or incompressible. So, whenever it is after taking divergence, if you are getting the answer 0, then we can say that it is a solenoidal or incompressible, or it is a divergence free vector. So, this is what the physical interpretation of this divergence. Let us discuss in more details in next video.